Graphene Flagship can't really be described as just an EU-funded project. And that because it is one of Europe's largest research initiatives, counting 170 partners in 22 European countries. And it has only one end goal, that of bringing graphene out of the lab and into commercial applications. Together with Piero Gamarra, Graphene Flagship business developer, and my guest for this episode, we are going to discuss all things graphene. Piero, thank you very much for joining me. And please explain to me, what is the role of the business developer in a project? Because this is a first for me.
Yeah, thank you very much, Areti. The role of a business developer in the flagship is to help the researchers to bridge the gap between the lab and industry. And we do this in different ways. First of all, we connect our researchers with possible industrial partners, industrial recipients of their technologies, and we help them to draw business plans in a, let me say, technology push process. In parallel, we also bring industrial needs, trends, roadmaps to the researchers in order to make them aware of the trends of industry and to address their research. We are a sort of, let me say, messengers of the industrial world in a research project.
Excellent. So you are a messenger of graphene. What exactly is graphene?
So very briefly, graphene is a single layer of carbon atoms, or if you prefer, is a one atom thick layer composed of atoms arranged in a lattice, on an hexagonal lattice. It is the thinnest material made by the humans, and since there is no way to go below the thickness of one atom. Graphene was isolated first in 2004. In 2010, Professor Andre Geim and Professor Novoselov have been awarded with the Nobel Prize for the discovery. And since then, a lot of research has been made on graphene. Graphene is conductive, flexible, extremely light, as you can imagine, and selectively permeable, and this opened the path to a lot of applications.
Okay, I admit ignorance on the Nobel Prize thing. I didn't know that, but then again, I wasn't 100% sure of what graphene is either. So now would you also please describe for me in a few words what the Graphene Flagship initiative is?
As you said, the Graphene Flagship is a one-of-a-kind European project. Since it has a huge budget of about 1 billion, a long duration, 10 years in 2023. And it serves as a sort of technology accelerators. So on one end, Graphene Flagship supports basic research on graphene, but also on other bidimensional materials that are studied in the labs. And on the other end, we support the translation of the results to our industry and markets.
I know I said also at the beginning that you have about 170 participants from 22 different countries. So could you please tell me who is involved in the project, but briefly?
Yeah, of course, I cannot list all the 170 partners. But what I can say very briefly is that we have universities, research centers, of course, big industrial players, European industrial players, SMEs. And maybe one interesting thing to say here is that we have 16 spin-offs, so 16 startups which were born from the Graphene Flagships during the 10 years of the project.
All of them working on graphene?
All of them working on graphene.
Impressive.
And all of them producing graphene and graphene-based products for different markets and different applications.
Impressive. And who are they producing it for? Who is the target audience?
Well, the target audience is various, since graphene is a material with a lot of possible applications. So, of course, since we are at Enlit, we can say that the energy sector is one of the main audience, main market for graphene, for different applications, from energy generation to energy storage, but also for electronics, sensors, and I would say composite to reduce carbon emission.
Okay, that sort of covers, in a way, my next question, but I would like to insist and ask you about the needs of the EU energy sector that it covers and how.
Yeah, this is a very good question. As I said, we are covering different fields. For example, in the field of energy generation, we are developing the next generation of solar panels. As you probably know, current solar panels are based on silicon technology. And one of the ideas to improve the performances is to realize the so-called tandem solar cells, in which you put the standard silicon cell and you couple it with another cell absorbing the part of the spectrum which is not absorbed by silicon. In the project, this is done using a perovskite solar cell, and graphene enable the realization of this tandem solar cell, which has an improved efficiency compared to standard silicon. Another interesting application is in batteries. So in batteries and supercapacitor, graphene can be used as an electrolyte to improve the performance of the electrolyte. And this is one, I would say, advanced application. Another possible application is that graphene enable the use of silicon as an anode in lithium-ion based batteries, which is an old topic, and the commercialization of silicon anodes is stuck due to the fact that silicon is expanding during charging and discharging of batteries, and graphene enables the reduction of this expansion and compression of silicon anode, and therefore the implementation of silicon anodes in lithium-ion batteries.
Okay, so as you said, there will be quite a few commercial applications, but is it feasible to be commercial on a large scale also, and how soon?
Well, there are fields in which graphene is already commercially available, and graphene-based products are already there. One field I can mention is the field of composites. For example, in composite, graphene is added to improve the thermal conductivity, or sometimes the electrical conductivity, or sometimes to reduce the weight of the composite. You can imagine, for example, in automotive or in aerospace market, in which a lot of composites are used. Graphene can reduce the weight of the whole structure and therefore the fuel consumption of cars and planes.
Okay, so I know that Graphene Flagship was awarded an additional 20 million investment by the European Commission for the creation of an experimental pilot line for graphene-based electronics, optoelectronics, and sensors. Can you please elaborate a little bit on that? What does it consist of? What are the benefits? Why was it needed?
Yeah, as I said, there are already graphene-based products for composites. Graphene-based products in the field of energy storage and energy generation are coming. The next wave of graphene-based products will be related to the use of graphene in microelectronics and optoelectronics. To realize those kind of products, we need to integrate graphene with the existing silicon technologies used in all the microelectronics world, in the foundries. And the idea of the 2D EPL is really to implement the use of graphene in a wafer scale process to develop new kind of devices, mainly sensor, but not only, to be then used in the system of industrial partners.
So I will admit here that I'm definitely not an expert on this topic. However, from our conversation, I already, let's say, believe that graphene will be quite important for the energy transition of Europe. Piero, thank you very much for speaking with me, for having this interesting conversation.
Thank you very much, Areti.
And thank you for joining us.
Thank you.